Today we're doing 8th grade, Chapter 1, Lesson 3, Negative Exponents. We talked about exponents yesterday, and that would be this little number up here. It tells us how many times we're going to be multiplying the base. So that means that we're going to multiply 10 times 10 times 10. And we learned that yesterday that with tens, the exponent tells us how many zeros we get. So tens are a little bit easier than most numbers. So if this one has 2 zeros, that means the exponent was 2. And if the exponent is 1 0. So what if the exponent is 0? Then you'd have no zeros and it would just be 1. And actually, any number to the exponent of 0 is 1. So x to the exponent of 0 equals 1, as long as x does not equal 0. But what happens if we have a negative exponent? So 10 to like the negative 1. When we had an exponent that was positive, we added zeros. And when we add zeros, it's kind of like we're moving the decimal over that many spaces. So if it's negative, we're moving the decimal back. And the exponent tells us how many spaces we're going to be moving it back. So 10 to the negative 1 would be 0.1, or 1/10. 10 to the negative 2 would be 0.01, or 1/100. 10 to the negative 3 would be 0.001, or 1 to the 1,000th. Any number to the negative exponent is just going to be that number as the denominator with a positive exponent and a 1 as the numerator. Again, as long as x does not equal 0. Let's try some examples. 6 to the negative 3 just means that 6 goes as the denominator, 3 becomes a positive exponent, and 1 goes on top. Or if we had a letter, the base is a, so the base becomes the denominator, the exponent becomes positive, and a 1 is the numerator. So that's expressing it as a positive exponent. That's how we change a negative exponent to a positive exponent. Let's look at how we would solve some of these, or go the other direction. So if I wanted to take a positive exponent and change it to negative, I would just write 5 to the negative 2. So I took the denominator and made it the base, and made my exponent negative. Now this next one's a little bit tricky because it didn't write it as an exponent. So how could we write 36 as an exponent, exponential form? How about 6 to the second power? So if I wanted to write it as a negative exponent, I'd take the denominator of 6 and make that my base, and the exponent would become negative 2. Let's look at the worksheet that you're supposed to do independently, your independent practice. Number 1 and number 2, you're supposed to be writing as positive exponents. positive exponents. So if I have a base of 8, I write that as the denominator, and my negative exponent becomes positive, and a 1 as the numerator. 3 and 4, you're evaluating the expression. They want you to write that as a positive exponent and then actually solve it. So, for example, let's do number 4 because it's got all those negatives. First, I take the base and write it as the denominator and change the exponent to positive. Then we put a 1 as the numerator. Now I want to solve that. So 1 is going to stay on top, but the bottom is negative 7 times negative 7 times negative 7. Well, 7 times 7 is 49. Times 7 again, it would be 343. And I have an odd exponent, so that makes my answer negative. So negative 1 over 343. Five and 6, you're going to just express them as a negative exponent. So I'm going to rewrite that, but with a negative exponent. Let's look at number 6. The base is E, and if I want to write it without the 1 on top, I change the exponent to be negative. Okay, we're going to skip number 7. You don't have to do number 7, but you are going to do number 8. 1 milligram is equal to 10 to the negative 3 grams. Write this number using a positive exponent. So you're just going to rewrite that with a positive exponent.